So welcome along everybody to this Martin Audio webinar training. Today's subject is our point source product range and their deployment. So we're going to be taking a look through our product catalog of point source loudspeaker systems and looking at some technical tips on how we can best deploy them to get best results for our listeners. My name is Robin Dibble. I'm a product support engineer here at Martin Audio. I'm part of a team of guys around the world who look after all the technical support for our customers' needs, our distributors' needs around the world. So that could be compiling training webinars or training days through to system design and commissioning wherever we're required. And it's a great pleasure to be talking to you today about some of our point source loudspeakers and a few tips and tricks about point source loudspeaker deployment. We're going to be looking at Martin Audio's two-level approach to the point source marketplace. So within each section, we have a professional solution and a premium market solution. And we're going to be looking at our loudspeakers in the commercial marketplace, installation, portable loudspeakers, portable powered, and also stage monitoring solutions. So we'll move right along and get started by talking about our commercial offering, and that's the Adorn series. So the Adorn series was introduced about a year ago now with two wall mount loudspeakers, and the whole series has been designed and engineered for the commercial sound marketplace with the priority of bringing Martin Audio's signature sound quality to regions where sound quality has not necessarily always been the paramount concern. So we're thinking about transportation terminals, bars, cafes, restaurants, reception areas, those kind of applications, but also through to things like educational AV and corporate AV suites, those kind of applications. The key thing is bringing Martin Audio's sound quality to this means that Adorn can be not just part of that marketplace, but can move into the larger venues as sound support in things like corridors, reception areas, those sorts of things, keeping the Martin Audio signature sound running all the way through a building as you move into auditorium spaces or performance spaces. So the ceiling speaker range has three models. There is one using a 4-inch low frequency device and two which use 5¼ low frequency. They all have 70 100-volt line multi-tap transformers on board, and you can see those are accessible from the front baffle of the ceiling loudspeaker. So if you do need to change anything after installation, that's very easy to do. You can simply remove the grille, which is fitted by a nice easy bezel, bayonet bezel attachment. Take the grille off, change your tapping as required, put the grille back on. Easy fit into any ceiling. If you choose to use low impedance mode, then they present a 16 ohm load, so you can put multiple speakers on a low impedance amplifier channel, getting really good value for money and your installation and in terms of amplifier cost. So the 4-inch has 180-degree conical dispersion, rises up to 10 kilohertz, with a peak SPL of 109 dB. Its -3 dB point is at 106 Hertz, which is pretty impressive when you consider this is sitting in a very small, shallow, 100mm deep back can. Now, the reason for this is that in many installations these days, be they on land or on cruise ships, there's very limited space above a finished ceiling to fit a loudspeaker. So keeping the back can depth to a minimum is very important, which is why we also make a 5¼ version in the ACS55, which, although it doesn't have the low frequency extension because of the shallow back can, does give a higher peak SPL at 113 dB by virtue of having the large drive unit. And finally, there's a version using the 5¼ low frequency with a deep back can, so we get better low frequency response down to 98 Hertz at -3 or 62 at -10. As peak SPL stays the same at 113 dB. Both the 5¼ versions have 150-degree conical dispersion. Now, a pendant loudspeaker is a very new thing to Martin Audio, a very popular solution these days when we have so many restaurants and bars, and of course supermarkets, DIY superstores, where there is no finished ceiling. So the loudspeakers need to be suspended from the roofing structure itself, and that's where a pendant style loudspeaker comes into play. Now, there's a lot of poor quality versions of pendant loudspeakers on the market. This one has Martin Audio's signature sound quality. All the same benefits as the ceiling loudspeakers. This has 109 dB peak SPL and a frequency response of 98 Hertz to 20K. good low frequency performance because of the tuning and the size of the enclosure on the rear of the Pendant loudspeaker. The Adorn series started with the wall mount loudspeakers. There's again 4-inch or 5¼ low frequency. Injection molded compact enclosures. They're packed as pairs and they come with a wall bracket included. They're two-way passive designs. The crossover has protection individually for the low and high frequency drivers, so that should they be overdriven, and in the commercial marketplace, often the guy behind the till is a bit too generous with the volume control, we end up with clipped amplifiers, so driver protection is an important thing. Separate on the woofer and tweeter so that you don't completely lose a box if it goes into protect mode. You can put them in horizontally or vertically. Standard low impedance version again is 16 ohms, so we can put multiple speakers on a single amp channel, or you can order them with a transformer fitted, and then we have the multi-tap on the front baffle as with the ceiling loudspeaker. So that's the baby, the A40, 4-inch low frequency down to 98 Hertz at -3 dB, 109 dB peak SPL. They're both 110 degree horizontal by 80 degree vertical. The 55 takes the maximum SPL up to 113 and gives us the broader bandwidth, larger enclosure and larger drive unit down to 90 Hertz at -3 dB. They're both perfectly happy to be used outdoors. There is an accessory available for them in a connector cover, which goes on the rear of the loudspeaker, making it IP44 rated. They're perfectly happy then sat left installed outdoors around patio areas, bar areas, those kinds of applications. So I'm going to take a moment now to have a look at 100-volt line systems and how they work. It's a much misunderstood area of commercial sound installation and worth having a quick look at, I think. So the idea of a 100-volt or 70-volt line system is to be able to have a loudspeaker or many loudspeakers remotely located from the amplifier whilst overcoming the loss that you would get in a long cable run. It also allows us to connect multiple loudspeakers in one zone to one amplifier channel, so it gives great savings in the cost of deployment. So a loudspeaker circuit is made up not just of the loudspeaker drive unit itself, but also of the send and return parts of the cable that are connecting to it. So let's have a look at an example of power loss in speaker cable. We take an 8-ohm loudspeaker as value R1, so that's the main load. If we connect that directly to a power amplifier and look at it against using it on the end of 100 meters of 1.5 millimeter cable. So the resistance of this type of cable, regardless of type, if it's a 1.2 square millimeter cable, over a long run will be 1.2 ohms in each leg. And we're going to assume an amplifier output voltage of 30 volts. So if we connected that R1 load, that loudspeaker, directly to the output of the amplifier or via some very short cables, the power dissipated into that load by the equation P being equal to voltage squared over resistance is 112.5 watts. Great. But if we include the series resistance of the cable, then that picture looks very different. We actually end up with 86.5 watts in the circuit rather than 112.5. That's because the resistance in the cable is quite a high percentage of the total load on the amplifier. So we end up losing 26 watts or just over a dB of level in our 100 meters of speaker cable. This could be a real issue if you're sat there scratching your head wondering why your speaker system doesn't meet the required SPL specification that you said it would if you haven't taken cable loss into consideration. Now imagine what that would be as well if we had lower impedances, so more speakers on the end of that line, then the losses are going to increase. Let's look at the alternative using a 100-volt line system. So to do this, a transformer is used to convert the impedance of the drive unit from 8 ohms to 100 ohms. So it's presenting a 100 ohm load to the power amplifier. The resistance remains the same, 1.2 ohms in each leg, but we're going to look at it at the full output voltage of a 100-volt line amplifier, 100 volts. So total power into the load, if it was connected directly to the amplifier at this point, would be 100 watts given by the same formula. So very similar to the previous example. If we now include the cable resistance, the resistance goes from being 100 ohms to 102.4. So the cable resistance is a much, much smaller part of the total load circuit. So power dissipated into that circuit is 97.65 watts. So 2.35 watts lost somewhere, or 0.1 dB, which is clearly an improvement over the previous example. Now, 100-volt line systems have received a lot of denigration over the years for the fact they don't sound very good, or they're not good enough for music. Well, I would contend that's not necessarily the case. There are a lot of situations where a 100-volt line works extremely well. And if you use a modern 100-volt line power amplifier, for example, our IK81s, which have a transformerless output stage, they don't have the band limiting that a traditional 100-volt line power amplifier does. So you can still get very wide frequency response. Combine that with a well-designed transformer at the load end with your loudspeaker, and you can get really wide bandwidth from a 100-volt system, all down to the speakers that you choose and how you put the system together. What are these 100-volt line loudspeaker tappings we're talking about? Well, the rotary control that you can see here in the front of a CDD-5, you can see tappings there for 25 watts, 12.5 watts, and 6 watts. What they're doing is selecting windings on a variable transformer to give a different load impedance. Although it's all quoted in watts in 100-volt line world, what you're actually doing is changing the load impedance that the loudspeaker represents to the power amplifier. This is a really useful feature on these type of loudspeakers because it means, for example, if you have a room with high and low ceiling areas, and you have all of them on one power amplifier channel, it enables you to change the power that's being delivered to each loudspeaker to balance volume within a room. The other advantage is you can have multiple loudspeakers on a single amp channel. This is a key thing with 100-volt line systems and why they're deployed in transport terminals, in large retail outlets, those kinds of applications in so many cases. It makes it very cost effective to deploy multiple loudspeakers if you only need one power amp to drive them all. So the way this works is that as long as the total connected load of the loudspeakers, so in this example we have 8 loudspeakers tapped at 30 watts, as long as the sum of those powers is below the rated power of the amplifier, and 100-volt line amplifiers tend to be rated sort of 240 watts, 250 watts at 100 volts, as long as that load is below that stated power, then you're in. That's fine. You won't overload the amplifier. Everything will work nicely. Now, this may sound like black art, just adding a power rating up and sticking them all together and connecting them to an amplifier. But when you understand what's really happening, that's not the case. It's just the same as a low impedance system. We've just made the load impedances higher. So load impedance higher, voltage on the line higher, we're still dissipating the same amount of power into the loudspeakers. So our 30 watts at 100 volts equates to 333 ohm load of each cabinet. These are just parallel together. That results in an impedance of 41.3 ohms, which at 100 volts is 240 watts. So no different to a low impedance system. We're just paralleling load impedances up and presenting a load to the amplifier that's within its load rating. In terms of ceiling speakers, how do we make them work? How do we plan a ceiling speaker installation and how do we put it together? Well, we need to ask yourself some basic questions to start with. Firstly, what is the frequency range over which I want to get even coverage through the room? Because that's going to dictate the number of loudspeakers that you need and also their type. What frequency range do I need? Is this a speech-only system or am I playing music through it? That will give you an idea as to the frequency range you want from your loudspeakers. And of course, how loud does it need to be? That will tell us what size amplifiers we need, what tapping we need on our 100-volt loudspeakers, and also how loud each individual loudspeaker needs to be. So all of that can come from those 3 questions. Then finally, we look at how close they need to be together in the layout. So the reason we have to be careful about our choice is quite simple. 2 types of ceiling loudspeaker here. On the left is the Adorn 4-inch, lovely sounding speaker, great hi-fi music quality to it. And on the right is a standard commercial 6-inch ceiling loudspeaker. Okay, so the first shocker is that the Adorn for £110 list at its maximum power at 100 volts, which is a 20-watt tap, will deliver 99 dB, whereas our £30 speaker on the right-hand side will deliver a maximum of nearly 103 dB at just 6 watts. Might seem like an obvious choice towards the one on the right, but we need to look at other factors, which is why it's important to weigh what you need and decide on your approach. So, do we want hi-fi music quality? If we do, the one on the right really isn't going to deliver it. To start with, it has a very narrow frequency response, and within those frequency range, it's very unmusical with a very ragged frequency response through that range. It may be it's very efficient and it doesn't need much amplifier power, but its dispersion is not good. So up at 8 kilohertz, the dispersion is down to 40 degrees, whereas with the Adorn, it's at 180 degrees at that frequency with the 4-inch version. So we've got to balance what we're looking for: frequency range, musical quality, SPL, to pick the right product, because of course getting that right is going to have a big impact on your budget and also the ultimate performance of your system. Once we've decided our ceiling loudspeakers, we need to design the system in the room, and the most important consideration here is ear height. Is your listener going to be sitting down, or are they going to be standing up? If they're going to be both, you always need to design for the highest ear height that's closer to the loudspeaker, so that is going to define the distance of which they need to be apart. So we're looking here at the deep backhand 55 Adorns, and we have the coverage angle at 150 degrees at high frequency, and here you can see we're covering at ear height, but at standing height we're not. So we would need to move these speakers closer to the first one to bring their pyramids together so that the ear height standing is included within that distribution angle. We'll then have even coverage right up to our defined high frequency point. This can be done quite simply with a protractor, a ruler, a pen, and a piece of graph paper. Very simple, very easy, and very easy to calculate, and of course doesn't cost any money whatsoever. However, we do live in the 21st century, and there are some better ways to do this. To start with, we have on our website a very quick, down and dirty ceiling speaker position calculator, which will tell you how many of our C-series ceiling loudspeakers you need in a room for a given evenness of coverage across the space. Slightly more advanced, AFMG have a free to download piece of software called Access. This will allow you to plan ceiling speaker installations and produce some very pretty graphs and plots, which you can present to your customer to say, look, we're achieving our coverage plus minus 3 dB across your room by having this many ceiling loudspeakers deployed. You can also do exactly the same thing in AFMG's free Ease Focus 3, as long as the GLLs that you use are licensed in that application. Again, you just point the speakers down at the floor rather than pointing them left to right across the room, and you can use that to plan your ceiling speaker installation. Finally, you have the option of a full acoustic modeling package. Everything else we've looked at so far looks at direct sound only and doesn't take any room acoustics into account. But if that's something you need to do and you have the acoustic characteristics for the room you're looking at, Ease Focus 4 will show you the direct output combined with the acoustic output of a room and give some very accurate predictions. It's not cheap, sometimes not very easy to use, but it is extremely powerful and gives you all the answers you could ever need. So moving on to the premium installation bracket, let's have a look at our Coaxial differential dispersion series, CDD. The most successful range of installation loudspeakers that Martin Audio has ever made, because they sound fantastic and they look great. And they've gone into everything from houses of worship through to clubs, leisure, theatre, bars and restaurants. There's a model for every application from a 5-inch right the way through to 15, with a suite of mounting hardware available for pretty much every application. Now, the secret of their success is their sound quality and significantly the evenness of tonality across a venue produced by this thing here. This is the Coaxial differential dispersion drive unit, which combines the benefits of a true coaxial point source loudspeaker with that of an asymmetric dispersion pattern, which we call differential dispersion. Now, a conventional two-way loudspeaker system with a separate low and high frequency device has a bit of a problem through its crossover region. That's because you start getting out of alignment between the low and high frequency devices. When you're right in front of it, equidistant from both drive units, nice flat frequency response through the crossover region, as you can see. As you move off axis, that changes and we end up with that big dip in response you can see at the top right, because you are off axis between the two drive units. So the two drivers are out of phase in their crossover region, so they cancel rather than sum. And that will happen through all frequencies throughout that crossover range. So you can end up with a bit of a mess through that region, depending on how close you're standing to that loudspeaker. And the arrival times and therefore the phase response is different from each drive unit. So using a coaxial driver overcomes that. Now you can see in the balloon plot here on the left hand side, the traditional two-way, you can see that vertical cone filtering at the crossover region. This is a 12-inch two-way at 2 kilohertz. So you can imagine what the effects of that are going to be when you actually listen to it and you're anywhere near that, depending on what distance you are from the loudspeakers. Change that to a coaxial drive unit and things get very much better. You can see that now we have a nice coherent balloon plot, even level right the way through the crossover band, and that's because both sources are in the same place. Rather than discrete high and low frequency drivers, they're both in one position. So as you move around in front of that loudspeaker, your relationship to both drive units remains the same in terms of time and therefore phase, so no nasty cancellations. Now, traditionally, there's been a problem with coaxial drive units in that as you go up through the frequency range, their coverage angle reduces. So we're looking here at a traditional coax loudspeaker. Down the middle here is the zero axis, so that's right in front of the loudspeaker. Above it is off to the left and below is off to the right. And the grayscale is your dB drop off as you move off axis, 3 dB per color change. So you can see that as we go up from 4 kilohertz, our coverage angle narrows distinctly as we go up through the frequency range. So we get that well-known factor where you stand on axis of a coaxial loudspeaker and everything sounds great, you're getting the full frequency range, but as you walk off axis, you start to lose all the upper mids and highs, you lose the detail and you lose the intelligibility. The waveguides that we use in the CDD drive units are the reason why we can take control of that whole region and we can get them to go, get the dispersion to go where we want it to. You can see on the plot here that the beam width just is not suffering from this heavy narrowing through the frequency range. It's much smoother right the way from 4K up. That means that more people are getting more of the same tonal balance, which makes life a great deal easier for everybody, and everybody's getting the same sound quality. It's a win-win. Now, the reason this works is because of the waveguides that are built into the CDD drive unit. So there's a static waveguide, which you can see in the center of the drive unit, goes through the pole piece of the magnet, the diaphragm, and then we have the secondary waveguides on the cone itself. Now, this may seem counterintuitive, but in actual fact, the wider gap you can see at the top of the drive unit here, that's the bit that has the narrowest dispersion. So the slot loading there, because the slot is wider open, we don't have as much control. We're not widening the sound out as much, it becomes narrower. So we have a nice narrow coverage pattern at the top of the vertical to give us projection to the back of a room. At the bottom of the drive unit, where the narrow slot is, it gives us wider coverage. So in the near field, close to the loudspeaker, we've got wider coverage for people who are close to the boxes. This is what that looks like in the real world. So a conventional X by Y loudspeaker, we have this distinct hotspot right in front. We're all used to hearing it. It drops off as we go to the sides of the loudspeaker and we lose that upper mid and high as we get to the rear of the room. With the differential dispersion in CDD, you can see we're getting that coverage right out in the near field to the width of the loudspeaker here. We're getting almost a rectangular coverage across our audience space with good projection to the back of the room. Now, this really does make a significant difference in terms of sound quality for everybody. It also means that you need to put less speakers in because there are less gaps to fill. There's a CDD loudspeaker for pretty much every application, from the 5-inch through the 6, 8, 10, 12 and 15-inch versions. There's a whole range of subwoofers available to partner them in our SX series. There's now also weatherized versions of CDD, so you can put them in your outdoor areas, gardens, patios, outdoor terraces, those kinds of applications. and also a full marine spec. This takes the drivers and replaces all the hardware with very high grade stainless steel fittings, replaces the termination on the back of the box with a glanded rubber cable with a stainless steel 3-layer grille system on the front, which has been carefully designed to minimize acoustic impact whilst keeping water ingress away from the drive units. And the drive units are all, of course, treated against moisture ingress. Now, these are ideal in applications such as cruise ships, the outer decks on cruise ships, or beach bars, anywhere where you've got a really wet or corrosive environment. Okay, that's installation. Let's have a look at some portable loudspeaker applications. So BlacklineX is Martin Audio's range of loudspeakers that give exceptional sound quality at a very approachable price point. Now, Blackline was introduced back in the late 1990s for exactly this reason and was re-engineered about 3 years ago now from the ground up. All new cabinets, all new drivers, all new crossovers, with the goal of achieving the legendary Blackline sound quality and reliability, but at a more accessible price point. The R&D guys were completely successful in achieving this, and we have a range of great sounding multi-purpose boxes that will find homes in many applications. There's a model for pretty much every purpose through the range, starting with the X8, which is an 8-inch two-way, low frequency cutoff at 70 Hz and 121 dB peak. As we go up through the range, we have a 10, a 12 and 15-inch versions. And obviously, as they get larger, the output gets greater and the low frequency point to which they work goes lower. The other thing that changes is the high frequency horn. So the two smaller boxes are 90 by 50, the larger are 80 by 50. They all have these rotatable constant directivity horns. And also as we go up through the range, then the diaphragm size on the compression driver gets larger. So they're bigger drivers on the bigger cabinets because they have to cope with the lower crossover point that's demanded by the larger low frequency drivers and also higher power handling capacity. Now you'll notice that on all the cabinets there are M8 fly points all over the boxes. You can see the little blind screw holes there with the bolts in. These are all mounting points so you can fly the boxes. On the rear of the cabinets you can see mounting points for wall brackets. So you've got a wide range of mounting capability for installation purposes. But they also have very tidy handles on the back of the boxes, and they have discrete pole mounts in the bottom of them. So they're equally happy used as a portable loudspeaker. Partner subwoofers. Now the BlacklineX have their own partner subwoofers in the range. There's a single 15, 135 dB peak and 45 Hz at the low end, a single 18 and a brand new double 18. They're all great, excellent value subwoofers. Again, they can be permanently installed or used as portable. And you'll see they all have top hats in the top of the boxes so they can be used to support an accompanying Blackline top box. The X218 is worthy of a mention as it's a brand new product. This uses two new high power 18-inch drive units and what's quite a compact enclosure for a dual 18. 141 dB peak output and 42 Hz at -3 dB. Really punchy, dynamic and musical sub. It really is exceptional performance at its price point. From BlacklineX, we move on up to XD. So this is the premium portable loudspeaker range from Martin Audio. The XD series use premium quality drive units, tour grade cabinets, and are suitable for a wide range of applications, be that fill speakers in larger systems, a standalone PA on their own, in clubs, theatre, it's a very popular theatre box, and also corporate events. XD is the next level of multi-purpose performance after BlacklineX by having premium quality drive units and also dual purpose crossovers, so they can be run full range or bi-amplified. We get a peak SPL, full range of 130 dB from the 12, get an extra dB when you bi-amp. Again, it's a constant directivity 80 by 50 horn, and the 12 goes down to 65 Hz. It's truly multi-purpose, equally happy to be installed again, but you can also use them as a stage wedge. So as a higher stock item, it's a great loudspeaker to have. You can use it as a main small PA, or you can use them as stage monitors, as you can see here. The XD15 giving you a peak SPL of 132 in passive or 133 when you bi-amp it. Of course, the larger drive units and larger cabinet volume mean this goes down lower to 55 Hz. Very flexible deployment. There's a range of mounting hardware available from Martin Audio for the XD series for pretty much any application. And for those areas where we don't have the hardware available, you can design and build your own or fly them from the integrated M8 fly points that you can see all over the cabinets. Then we come to the big boy of the point source range. This is the TH series. There's a THH, which is the one you can see here. Sorry, this is the THV, which is a vertically aligned one. And there's a THH, which is horizontal, you will see in just a moment. Three-way, fully horn-loaded, high-impact sound system for where you really need some dynamics and some punch. So live music venues, houses of worship, great club speaker system. And for the well-heeled mobile DJ who's got a large van, it's also a great solution for that with a couple of twin 18s underneath it. And yes, one of these will quite happily keep up with 2 twin 18 subs. That's because it's a three-way bi-amplified all horn loaded system, so it's very efficient. On the low end, there's a hybrid loaded 15, so that's a big horn in front of it and reflex loading behind for great punch and extension. Then we have a 10-inch mid and a 1-inch exit compression driver with a 70-degree horizontal by a 50-degree vertical dispersion. That applies to both the horizontal and vertical versions of the loudspeaker. Response down to 50 Hertz and a good maximum SPL of 139 dB peak. So we talked about planning ceiling loudspeakers. How do we plan our point source systems? Okay, so let's have a quick look at how we go about that. Now, of course, we can do the same as we did with our ceiling loudspeakers and get our rulers and pencils out. But this being the 21st century, I thought we'd highlight software packages. Now, many manufacturers now have their own in-house prediction software, and that's something that we at Martin Audio are working towards even as we speak. The software elves are beavering away to bring this to fruition. So for the moment, though, however, we have the AFMG Ease Focus 3 software package, which is free to download, which we use for our point source design. And for the larger systems and where you need the extra detail and acoustics taken into consideration, you can load all our loudspeakers into the full Ease 4.4 prediction software as well. Ease Focus is free to download from AFMG. You can find the address there or just Google Ease Focus 3. It'll soon take you to it. Once that's downloaded and installed on your computer, you then need to download the GLL files, as they're called. These are the electronic models of our loudspeaker systems from our website. You'll find those available for Adorn, CDD, BlacklineX, both passive and powered versions, the XD series, and also for our SX subwoofers. This is very useful, as we will come to see. Inside Ease Focus, all you need to do is create your audience areas within the project, and it'll cope with pretty much any audience shape or building shape you care to mention. Worth mentioning that it does work with direct sound only, so room acoustics are not taken into consideration, but it does give you a really good way of predicting how your loudspeakers are going to perform in a given space. Once you've defined your space, you drop your loudspeakers into it. It'll then produce for you very pretty colored maps of exactly what performance you're getting from your loudspeakers in the room. So you know what SPL you're getting, what your coverage is. It'll show you then quite clearly. You'll be able to see where you need to put extra fill loudspeakers, all those kinds of things in order to achieve your performance goals. You can use individual little takeout points, 1 and 2, you can see there. Place these anywhere within your model and it will give you a frequency response of your system in those locations. It also produces statistical analysis, so you can see how much of your room is within your desired dB specification. It's a great and useful bit of software for subwoofer planning. Now, planning your locations for your subs in a room can often be a traumatic experience because of the very long wavelengths that are involved. Getting the best placement to avoid negative interaction between loudspeakers can be really difficult. This allows you to map it within a room so you can see exactly what's going on, how they're summing up, where they're cancelling, and what's acceptable to you. Again, as you can see here, you can also put your measurement, your virtual measurement mic points into the model and look at the resultant frequency response across the room. This one's really good. This was a church in the United States of America. We were modeling a single hang of 6 SXH subwoofers in a cardioid configuration. So you can see we have great rejection at the back of the flown array here towards the stage, and good energy level moving out through into the congregation space. Because it was a single hang in the center of the room, we didn't have any interactions from co-located subs, so we end up with just level drop off in each location. As you can see, the frequency responses remain pretty much consistent, just changes in level depending on where you are within the room. Now, if you want some more deep detail on Focus or a guide on how to use it with Martin Audio products, I would point you in the direction of our website, martinaudio.com training, where there is a pre-recorded webinar on how to use Ease Focus. I think the current one that's on there I did as well, actually. Or alternatively, there's a whole load of bunch of stuff and training material from AFMG themselves. Okay, so we're going to have a look at some of the negative sides of using point source loudspeakers in a traditional configuration. So we've all seen two loudspeakers arrayed side by side in configurations such as this. Idea being getting a wider coverage in a single location you would get from a single loudspeaker system. Unfortunately, it's not as straightforward as you might at first think, because these two are not going to behave the way we want them to, unless you happen to be standing right in front of the pair. When you're equidistant from both speakers, you'll get a flat response from the two, but as you move off axis, something called a comb filter happens. So whereas before we were looking at interaction between two drive units over a narrow band of the crossover frequency, we're now looking at interactions through two full range loudspeakers. So we're going to get differing interactions through different frequency bands from the two loudspeakers, depending how far off axis we are from them in the horizontal plane. Meanwhile, if they happen to be conventional two-way loudspeakers, that's also happening in the vertical. So what you actually get at the end of it can be very, very unpredictable and really difficult to measure, because we can end up with some very erratic frequency responses, as you can see at the top right-hand side. What does that mean for the audience? Well, let's have a little look. So here's those two loudspeakers. They're X12s. They're mounted just above head high on a wall in a typical room. And we start off looking at 100 Hertz. That's fine. They seem to be adding together quite nicely, and everything is in the garden is rosy. Trouble is, we move to 200 Hertz. What's actually happening, because the two drive units are spaced apart, we start getting cancellations. So we start getting a narrowing in coverage. That's actually narrower coverage angle than a single X12 would be at that frequency point. Take it up to 500, well, we have this distinct and pronounced power alley down the middle and heavy cancellation everywhere else around in the room. Very, very uneven. Take that up to 1K, we have a different shape again, and this is all different interactions from those same two cabinets due to the differing wavelengths at different frequencies. So the question there is, how do you measure it? It's going to sound different in every single point, so where do you put your measurement mic? And how do you equalize that to get a uniform response? And the simple answer is, you can't. So in an ideal world, what we'd actually like to do is put a loudspeaker in there which gives us the same dispersion angle as that split pair, but is louder. Now, sometimes that's not always possible, but with a CDD, for example, we can get pretty close. So this is a CDD-12, a single one, and we can see at 4 kilohertz, we don't have all this combing and lobing because it's a single source. We've got a pretty similar dispersion angle. It's slightly quieter because there's a single loudspeaker. And these are all judgment calls we need to make in our system design, and our approach is what are our acceptable compromises and what do we need to do to get the performance we want within our space. So the next conundrum when we're talking about loudspeaker systems is, well, do I want a passive one or do I want a powered one? So let's start by looking at Martin Audio's powered offerings. BlacklineX Powered takes the highly successful BlacklineX loudspeaker, moves the handles to the side and puts a power amplifier with some processing in their place. Perfect application for these mobile DJs, portable band PA systems. It means you need a minimum amount of kit for maximum performance level. You don't have to carry racks of amplifiers or processing equipment. And in fact, in some cases, if you're a solo performer, you don't even need to take a mixing desk with you, as we will see. But equally, bars or restaurants where they sometimes put a temporary deployed system up for band performances, secondary rooms in houses of worship, all these portable applications are ideal for BlacklineX powered. But also, like all of our boxes of this type, they are multi-purpose. And you can see from the amount of fixings available on the cabinet, they're just as happy to be installed as their passive partners. And we'll have a look at why you might want to do that as we move through. So 2 models of top box is the XP12, 80 degree by 50 degree CD horn, 62 Hertz low frequency extension and 128 dB peak. You can see it there in its monitor application. And the 15, obviously louder at 131 dB peak and obviously more low frequency extension. Larger driver, larger cabinet, that's what we get. Both 1-inch exit high frequency drivers on the same rotatable CD horn. These are partnered with the XP118. This is a great high power single 18 sub, same brand new drive unit as in the X218, but this time it's a single driver cabinet with the power amps and stuff in the back of the box. 42 Hertz the low end and 137 dB peak. So XP takes the same ease of use and portability as its passive partners, adds the power amplification, but is equally applicable to installation or portable use. You can see now the pole mount in the bottom of the cabinet, same as on the passive version, and you can see that they're supplied with this blind gland to put in the bottom. So when they're used for permanent installation, left with an ugly metal top hat in the bottom of the speaker, it still presents a clean look. In the back of the box, we have a digital signal processor. This provides active crossover, 24 dB per octave between the low and high frequency devices. But also in there, we have a small mixer with EQ, and we also have different preset modes. That's all accessible by the rotary control you can see there on the left-hand side. Just turn and push for each function. Very simple indeed. It also has this small mixer facility with individual EQ on each channel. So for example, you could, if you're a solo performer, have your guitar plugged into one channel on the jack connector, microphone plugged into the other on an XLR, and you have your mixer in the back as well. And as you'll see, there's also a Bluetooth app coming for remote control. The third channel on that mixer is for Bluetooth audio streaming, and you can pair 1 or 2 BlacklineX powers to any Bluetooth source and have sound directly from them out to your loudspeaker system. The 3 presets on board, one is for standalone PA use, one's for using it with a sub, so a high pass filter, and the third is a discrete voicing for stage monitor use. So on a stage, you need a different tonal character to a main PA. You need a bit of bite and a bit of punch to get vocal through the background noise on a stage, and that's provided for within the presets. 2 power amplifier channels matched to the drive units, one for the low frequency and one for the high efficiency class D power amplifier with a power factor corrected power supply. So it's smooth, even draw from the mains under any circumstances, and it will run from 100 to 240 volts without you having to change a thing. This is the Bluetooth app, will be available in the App Store this summer to work on Apple iPhone or on an Apple iPad. Remote control of a pair of the top cabinets, so you can use that to control your mix if you're using the input, the dual inputs on the back of the box, and all the other functionality that's on the rear panel is duplicated on the app. Next up is the premium solution, and this is CDD-LIVE. So CDD-LIVE takes the coaxial differential dispersion drive unit we've already been talking about and teams it with class-leading electronics and power amplification, all packaged up nicely in a tour-grade enclosure. Everything from live sound reinforcement in small to medium-sized rooms through to portable corporate systems, theatre use, again, clubs, wherever you need a compact solution of exceptional quality with onboard electronics. In the package, we have the CDD-8. So this is the 8-inch two-way, 110 degrees in the near field, 80 in the far field at the top of the vertical, 70 Hertz low frequency extension, and 123 dB peak output. Pretty impressive for a very compact box. The CDD-12 uses the 12-inch CDD drive unit, so we're down to 70 Hertz now and 128 dB peak, and the CDD-15 up to 132 dB and down to 55 Hertz. There are two subwoofers to accompany them. There's a very compact single 18. This goes down to 47 Hertz at -3 dB with a peak SPL of 135 dB. Very compact enclosure, so that's why, even though it's got an 18 in there, the extension isn't terrific. But if you need that, we go to the dual 18, obviously double the power, dual driver, but it has a larger enclosure volume per drive unit. So now we get extension down to 35 Hertz and a peak SPL of 143 decibels. In the back of the box, we have a bunch of processing and we have 2 power amplifier channels. You can use them plug and play, just give them some mains and an analog audio signal into the XLR connector on the back panel here, and you can select from presets built into the cabinet. First one is to run the system full range. Second gives you a high pass filter for when you're partnering it with one of the subs. Third is for use as a wedge monitor, so that different voicing factor that we need for stage monitoring. The fourth, you can program your own favored EQ curve into the box and recall it anytime you like. You do that via the network control and our ViewNet software, which you can see here. So this gives you control individually over every cabinet across the network for level, parametric EQ, and delay. Or you can gang them together in zones, as you can see here. They will then control across each zone individually. So left-right pairs or different delay zones, you can pair up together. So one EQ change in one will be replicated in the others. Very flexible and easy to use. All you need is a network. And if you've got a network and a laptop, then we might as well put our audio down it too. So all the CDD-LIVE loudspeakers and their partnering subs all have Dante cards on board, all can be spoken to directly by any Dante system. From a portable point of view, this makes a very compact, high-performance system. So you have your digital console with Dante outputs, a laptop and a network switch out to your loudspeakers. That's it. No power amplifier racks to carry around with you. No rack of processing devices to carry around with you because it's all in the back of the boxes or it's in your console. So smaller vehicles, which makes life easier and less expensive for all of us. From an install point of view, this is great if you can't get anywhere to put your power amplifiers or you think they're going to end up in a poor condition through lack of servicing and get full of dust. These are all passive cooled, so there's no fan noise, so you can even deploy them in theaters without worrying about the fact you're going to get any noise from physical noise from the amplifiers in the back of the boxes. If it's installed, of course, all you need to do is give it power and connect it to a network and away you go. You haven't got to start putting heavy gauge speaker cords all the way around a building. As with all the other point source boxes we've talked about, the key point here is flexibility. So there are wall mount brackets that are available. There's a wide range of mounting hardware. And again, we have these M8 fly points all over the cabinet should you need to develop custom hardware or fly-by-wire using shouldered eye bolts. So when would you decide to use active or passive systems? So the advantage of an active loudspeaker is the key point is you need no external amplification. Great for a portable system, less room taken up in the car or in the van when you want to move it around. And for venues where you've got no safe place to put an amplifier rack, I'm thinking particularly things like bars here, where the amps always end up full of dust because the fans have blown it through them or with beer being poured into them every night. Very easy to deploy, you've just got to get a signal to it and mains, and there's no long speaker cabling, so we don't have power loss or quality loss due to damping factor reduction down our speaker cables. In a good quality active speaker, such as the ones from Martin Audio, the amps, the processing and the drive units are all perfectly matched to get the best possible performance from those loudspeakers that we can, the best SPL and the best sound quality. You can't do that necessarily when you've got external amplifiers and processing. And in any situation, if you lose an amp, well, or an amp channel, you may lose only one driver or one cabinet. Whereas if you're using separate power amplifiers, generally you'll have more than one loudspeaker connected to each amp. And so if you get a failure, you could lose all your mid-highs, for example. The disadvantage, well, for an installation, it may be tricky to access to get to the loudspeakers to take amplifier modules out of the back of them. Access to controls on the back of it may be a problem if they're in public areas. People can get to it and tweak it. And you need to plan to have a mains outlet adjacent to every loudspeaker. So the advantages of a passive are obviously the inverse of what we've just been talking about. The external amplification can be located in a central area for ease of access and maintenance. Makes life very easy in an installation. Your control is from a central location. You've only got to connect a computer in one place and away you go. It's simple to install. There's no local main supplies needed, and if the racks are locked away somewhere, it's completely tamper-proof. But the disadvantage is that in reality, most installed amps are very rarely cleaned and serviced. I know when I've been out to service calls, they're regularly full of dust all over the internal components, and are usually sticky from having beer or some such substance poured into them at some point in time. Active loudspeakers are sealed, and like the CDD-LIVE and the BlacklineX, they're often passive cooled as well, so you don't have these problems of getting dust and contaminants into the amplifier stages. You've got the risk of power loss and quality loss through long speaker cables, especially in certain installations where loudspeakers are a long way from the amps. And also the drive units are more prone to being overdriven. In an active speaker, limiters and amplifiers are carefully matched to the drivers, so you know they're always going to stay in control. If limiting is not properly set in a system, it's very easy to overdrive, or if someone's tampered with it. So the advantage there to the active is that it's much more set and forget. Okay, let's have a look at some point source stage monitoring. Again, two offerings from Martin Audio. We'll start by looking at the LE series, a legendary name with legendary performance. LE first started back at the very beginning of the company in 1971. The current LE range comprises two monitors which have tall grade enclosures, nice, easy to carry boxes with ergonomic handles. There are 4 connector points on each box. There are 2 at the front, you can see in this aperture here, and there's 1 in each end set into the carrying handles. The cabinets are protected both on their bottom corners and on their edges, so when they're dragged around stages, you're not going to damage the paint finish. Key thing here is we're again using our CDD drive units for this consistency of coverage. Just as important for a monitor loudspeaker on a stage as it is for your main PA, for the reasons we are about to talk about. But you will notice the CDD drive unit is now what appears to be upside down. There's a good reason for that. With a stage monitor, we want the wide coverage close to the box, so at the top of its vertical coverage for the space when the performer is close to the loudspeaker. As they move around in front of the monitor, we don't want any tonal shift pushing the performer off their performance in the near field to the loudspeaker. In this case, we want the narrow coverage at the bottom of the drive unit so we can project those upper, mid and high frequencies further upstage, maximizing the coverage as far as we can from each individual loudspeaker. 2 models in the range, as I say, starting with the LE100. This uses the 12-inch CDD drive unit, 129 dB peak, 78 Hz low frequency extension. It's a passive box, so runs from a single amplifier channel. Same physical features we've already talked about, but the LE100 has a nice extra feature in that it can be stand mounted. You can see the pole mount cover in the top of the box here, which makes it great for deployment, for example, as drum fills. Just put it on a speaker stand with the sub on the floor, as small side fills, or can even be pressed into use as a small PA if required. The LE200 is the larger unit, uses the 15-inch CDD driver, 133 dB peak, 68 Hz at the low end, and this can be used passive or bi-amplified. There are times though when you need to take your stage monitoring to the next level, and that's where XE comes in, designed for the largest, most prestigious stages in the world. And as you can see from the physical design of it, it's quite a different beast to anything you've seen as a stage monitor before. Inside the enclosure, again, we have its tour grade enclosure with easy to carry handles, 4 connectors on each cabinet again, and we have the same protection to the box. But an extra feature in the XE monitors is the built-in kickstand. So when you need to tilt the monitor more upstage, you can just drop 2 legs out of the bottom of the cabinet and change its coverage angle that way. So no more having to reach into the mic box to try and find a DI to wedge it in place with. Now, the really key thing that's different about these speakers, you can see, is the waveguide. So we're now going through the pole piece of the magnet from the diaphragm at the back, you can see there, right the way up through the pole piece, the waveguide extended right through the full depth of the cone and out onto the baffle itself. Now, this is also a very different next level CDD drive unit. Extremely high power, very, very rugged, and designed to give absolutely the best possible performance in this size of enclosure. These waveguides that go right the way through the box mean we get exceptional pattern control right the way through down the mid-range and vocal range of the loudspeakers to keep things focused where we want it and keep it away from where we don't. That's slightly different with the XE series to the LE series. So again, it's differential dispersion. So we have this almost rectangular coverage from each individual loudspeaker. But in these monitors, it needs to be from a narrower perspective, because on the larger stages, you're going to have performers with more than one wedge. So we want narrower coverage, so reduce comb filtering between adjacent cabinets. It also means that you can focus the sound more to each performer. So for example, your lead singer is probably not going to want to be hearing the spill from his bass player's monitor mix. Two in the range again, the XE300 using the 12-inch drive unit with a 1.4-inch exit high frequency, passive or biamped with a peak SPL of 140 dB when it's in biamp mode. Now the LE amp monitors you can put with any amp you like, as long as you put the right processor settings in the amp that accompanies them. But the XE series are exclusively partnered with the IK42 power amplifier from Martin Audio. Now there's various reasons for that. One is it means you can control all the amplifiers in your monitoring suite from the same packages you might be using for your front of house in our ViewNet software. It also means that we can take really good control of the speakers through the advanced 3-stage limiting that's in the IK amplifiers. And that's what allows us to get these exceptionally high SPLs from our loudspeakers without damaging them and without affecting their sonic quality and their dynamics, even when they're being run at their absolute limits. The XE500, same format, but with the 15-inch drive unit. Peak SPL is now 143 dB, and this runs bi-amplified only. So talking of SPL, that's an awful lot of noise level from a little wedge. So what are the realities of how much SPL we need, not just from a monitoring point of view, but generally when we deploy a sound system? Well, a point source loudspeaker's output is entirely dependent on something called the inverse square law, which says that for every doubling in distance from that source, there will be a level drop of 6 dB. So as energy is radiated within a space from a point source, it is obviously dispersed over a larger area. The further you get away from it, that source is radiating its energy into a larger space. That's why the level drops off 6 dB per doubling of distance, because it's covering a larger area. So bearing this in mind, how loud do our speakers need to be? Well, the first thing you need to remember is that watts tell you absolutely nothing about the output level you're going to get from a loudspeaker. They're useful for telling you how much power you get from an amplifier, but from a loudspeaker's point of view, all it tells you is the rating of the loudspeaker before the voice coil reaches its thermal limit or burns out. The key figures we need to know are the maximum SPL of the loudspeaker and its efficiency, i.e. how good it is at turning those watts into decibels of sound pressure level. So we go to our data sheet. So for example, we're looking here at a CDD-12 on the Martin Audio website, go to its specification, and you can see here that its rating is 97 dB at 1 watt at 1 meter, and it has a maximum SPL of 128 dB peak. Little thing to note here, Martin Audio, we express our peak values as 6 dB above the average. That's reasonable, and most power amplifiers you would specify could have the ability to generate 6 dB peak over the rating. But a lot of manufacturers are now using 12 dB or more for that crest factor. So it's just something to be aware of when you're comparing loudspeakers with other manufacturers, is that you're actually comparing apples with apples. Okay, nasty looking formula at the top of the screen. Strange title for a PowerPoint slide, but there is a reason. This is the formula that is used to calculate SPL drop over distance. It's actually not as bad as it looks. All we need to know is L1, the level at known distance D1. So let's say 97 dB at 1 meter, our original specification of sensitivity or maximum level. L2 is the distance we're going to be away from that loudspeaker that we want to find its SPL. Okay, so that's D2 combined with L2. Now we plug those two numbers into the formula. And let's assume we have a speaker with a maximum continuous SPL of 120 dB at 1 meter. We want to know how far it's going to be 5 meters away. So we plumb those numbers, the original distance, D1 and L1, against our new distance, D2, and that will give us L2, the resultant sound pressure level. So you can see the formula on the right there. It actually looks much easier when you break it down. Level 2 is equal to, in the end, 120 minus the 14 dB we lost by the 5 meters distance, which gives us 106 dB. Now, in most rooms, of course, we're not going to have just one loudspeaker. There's going to be multiples covering a particular area. So we need to look at what our total SPL in that space is going to be. Now, in certain and very particular cases, every time you add a doubling of the number of loudspeakers in the room, you get another 6 dB of level. Now, that only happens if it's the same source, same places, and everything's perfectly in phase. In most cases, of course, that's not going to be true. And in those cases, you get an extra 3 dB every time you double the quantity of loudspeakers. So, for example, one speaker gives us 100 dB at the required distance. If we have 2 of them, that becomes 103. 4 of them, because we're doubling, gives us 106, 8, 109, and so on, if we're looking at being equidistant from each loudspeaker. So think of standing in the middle of a nightclub dance floor with 4 speakers pointing at you, one from each corner. The formulas are there at the bottom of how we add multiple sources together in times when we might be adding multiple sources of different sound pressure levels. So non-coherent is what we are in most circumstances. Coherent is when all the speakers are the same and their source material is all the same. Of course, there are much easier ways to do this. Again, we do live in the 21st century, so you could, of course, use an app to add up your sources. There's the PA Calculate app, for example, in the web store, or there's the classic audio tools, both of which give you methods of calculating all sorts of audio stuff. Audio tools has the advantage, although it costs you a bit, of also performing as a sound level meter and spectrum analyzer, and is also capable of doing a lot of smart-like FFT analysis. Or again, you can use prediction software like EaseFocus 3, the free one that we were talking about earlier, or if you really need the best of the best and you need to take room acoustics into account, you can go for the full AFMG Ease 4.4, although that might cost you a few quid. But using software does mean, as we've seen, that you can get more accurate representations of the sound pressure level and frequency response within a room than you can by more basic calculation methods. Definitely worth looking at. If it's not something you've played with before, do download EaseFocus 3 there and have a look at our webinar, which will tell you how to use it, and you can get some really useful results out of using these types of software.